Hi everyone. In today's video we are going to be finding probability using combinatorics. Now you might ask, what are combinatorics? It's using either permutations or combinations for theoretical probability of an event. Okay, and here's our situation. All right, what if you and some friends are playing poker, okay, and you're dealt 5 cards. You want to know what is the probability you get a pair of 7s, right? Well, just to keep it it's straight, a standard 52 card deck has 4 suits: hearts, diamonds, clubs, and spades. It does not matter which combination are 7s, right? Each suit contains cards numbered 2 through 10 and an ace, jack, queen, and king for each suit. Okay, so there are exactly 4 7s in the deck of cards. A 7 of hearts, a 7 of diamonds, a 7 of clubs, and a 7 of spades. It does not matter what order you are dealt your 7s. They don't have to be the first 2 cards or first and the last, so we are using combinations, not permutations. Remember, permutations, orders counts. Combinations, order does not count. So, there are a few things that we need to find in order to be able to use our combinations, okay? Now, what I'm going to do is I'm going to get a text box. Let me get a big one, okay? All right. First thing we need to find are the number of combinations of getting 2 7s from 4. So there's 4 7s in the deck. So combinations of 2, let me put a dash in there, 7s from 4 7s. Okay, that's one thing we have to find. Okay, now the next thing we have to find is the number of combinations of 3 non-7s. So I'm going to use the pound sign for number. Number of combinations of 3 cards, because if we have 2 7s, 3 of the cards cannot be a 7 because we have 5 cards total. 3 non-7s out of, now 4 cards are 7s in the deck, so that means there are 48 other cards. Okay, so out of 48 other cards. Okay, that's the second thing we have to find. Now, the third thing we would have to find is the number of 5 card hands with 2 7s. So, number of 5 card hands with 2 7s. All right. And then we would need to find the number of possible 5 card hands. So the last thing we need before we can put it all together is the number of 5 card hands. That means the total number, okay? So think of that as our grand total. So maybe we might want to insert the word total in front. Okay. Now, I'm going to get my pen, and we're going to calculate each of these items. Now, we are going to be using our calculators. So the number of combinations of 2 7s from 4 7s. So there's 4 7s in a deck. If 2 of them are 7s that are going to be in our hand, that means we are going to be using that NPR form and CR, excuse me, because we're combinations. Okay, so that means there are 4 7s in a deck. Number of combinations taken 2 at a time. Okay, that's what we're going to use there. Then the number of combinations of 3 non-7s out of the 48 other cards is 48 C3, because 3 of our cards come from the other 48 cards. Now, the number of 5-card hands with 2 7s in them would be the multiplication of these two. So I would have to take 4C2 times 48C3. And then our total number of hands, possible 5-card hands in a deck, is 52C5. Okay, so this product is going to be our numerator. So probability of 2 7s, okay, in 5 cards, I'll abbreviate. So we have 5 cards in our hand, 2 7s, all right, would be this. We would take our 4C2 times 48C3 divided by the total 52C5. Okay, now 4C2 times 48C3, when I put it in my calculator, is this: 103,776 combinations out of a total of 2 million, wow, big number, 2,598,960 for my denominator. Now, if I take this and I divide it, because we don't want to leave it like that, we get this as a decimal: 0.0399. Okay, let's round this to the nearest hundredth. So it's approximately 0.04, changing to a percent, 4%. So about 4% would be the probability in getting a hand of 5 cards dealt to you with a pair of 7s. All right, have fun computing.